Hello, my name is Alexander Dart, and I'll be presenting Problem 10.4, Part C from the Elements of Chemical Reaction Engineering, 4th edition. The problem we are looking at today is Part C, and we'll be deriving the rate law for the synthesis of T-butyl alcohol, TBA, assuming the reaction follows the Ely-Rideal kinetics, which are given here, Is plus W yields TBA.S. and that the surface reaction is limiting. We start here with our first equation. This is equation 1017, which can be found on page 667 of our book. We have Rs equals Ks, parenthesis, Cis Cw minus CTBA dot S over Ks. The Rs is the rate of the surface reaction. Ks is the rate constant for the surface reaction. The Ks, the uppercase S, uppercase Ks at the end of the equation is equilibrium constant for the surface reaction. All of the C's are concentrations of whatever substance is listed in the subscript. Next up, we'll be looking at the rate of adsorption and some relations that we are given by the fact that it is a surface reaction that is rate limiting, or that is the rate limiting. And we take a look at our first equation that's listed on this slide here, RAD.I equals KA.I, parenthesis, CI CV minus CIS over K1. From page 734 in our book, heading 5, since we know that the surface reaction is rate limiting, we know that RAD over Ka is approximately equal to 0, as shown there. Using that relation, we can substitute the original equation back in. Using this, we can substitute this all back in. And we see that we have KAI, the stuff inside the parentheses all over KAI. When we have these over each other, we can cancel them out, and then we can subtract, or we can add the CIS over K1 to the other side of the equal sign, yielding this. And if we simplify, we find that CI CV K1 equals CIS. Almost exactly the same thing happens here. We have a similar relation for RD over KD, which is approximately equal to 0, and we do the same math, and we come to CTBA.S equals CTBA CV over KDTBA. Using these two equations that we just derived, we can plug them back into our original equation, and we find Rs equals lowercase ks, parenthesis, uppercase Ki, Ci, Cv, Cw minus Ctba, Cv over Kdtba, Ks. We can pull Cv out to the outside, and we yield this. Next up, we will find a relation for Cv using equation S10-7 on page 734. That equation is Ct equals Cv plus Cis plus Ctba.S. We'll use the equations we've derived before to plug in for Cv and CIS, CIS and Ctba.S, and we'll solve for Cv, yielding Ct over 1 plus K1 C1 plus Ctba over Kdtba. Which brings us to our final portion here. We've plugged everything back into our original equation, yielding our final answer of Rs equals Ks, parenthesis K1 C1 Cw minus Ctba over Kdtba Ks, close parenthesis multiplied by parenthesis Ct over 1 plus K1C1 plus CTBA over KDTBA. Thank you very much for listening to this presentation. If you have any questions or comments on how I can improve, please feel free to leave them in the comments below. Have a good evening.